So we can sense the existence of the dark matter through gravity. So that's the only way we see it. In terms of galactic weather or gas in the galaxy's halo, we actually don't really feel the existence of the dark matter. And but what we know is the distribution of the dark matter halo, because it interacts with other material through gravity. So the existence and the distribution of the dark matter halo actually affects where you're going to see all this gas. So they do have connection, but how that connection happened and where you can exactly find them are something mysterious that we're still trying to figure out. Does that make sense?
Yes, thank you, Dr. Zheng.
Yeah. I got a question in the chat from Jim, and the question is, how can you get the empirical data to model processes that take place over millions of years, and where does that data come from? That's an excellent question. So we know we are sitting here and we can only understand what's going on right now. So how can we collect data to understand the history of the universe? We do it actually through collecting large of data from different galaxies. So I observe this galaxy and I get one data point, and I observe that galaxy, and then I get a second data point. Then I repeat this process to observe millions and billions of galaxies, and then combine the data together, and then to see if there are any obvious trend in it, and to see if this part of this cluster of galaxies looks similar, and whether they have the same age and the same mass, and whether this cluster of galaxies have relatively less mass compared to other galaxies. So we do this research by collecting a large sample of galaxies together and then map it out at different locations. So we don't really study one single galaxy throughout its evolution history, because that's impossible to deal with. And then where does the data come from? This depends on what kind of telescope we are using. Basically, we can use, for example, optical telescopes. And as I show you, the Hubble Space Telescope can operate in the optical wavelength. So that has been one great tool I've been using so far. We also use other telescopes such as radio telescopes or infrared telescopes that operate in the wavelengths that we don't really see with our eyes. But those have helped us to understand the universe from different aspects as well. Does that make sense? Yeah. So let's see. Oh, Rara is leaving. Thank you, Rara. Yeah. Let's see. You're concluding. Tucker asked, your talk's concluding summary included the notion that galactic weather keeps the galaxy alive. Can you elaborate on that? Yes. So when I say the galaxy is alive, I mean this galaxy is actively forming stars, like our own Milky Way. Our own Milky Way is basically forming stars. It forms basically solar mass, which is the mass of our sun, every year. So by saying it's alive, I'm saying this galaxy is actively forming stars. When does a galaxy die? The galaxy is still there, we can still see it, but it does not form new stars anymore. So why the galactic weather is important to keep the galaxy alive? This is because through the hydrogen rain from the halo to the galaxy, it sustains the star formation process of the galaxy. This process is kind of like, I sometimes like to think about it as an egg, and the galaxy halo is the egg white, and the galaxy is the egg yolk in the center. So the egg white has all the nutrients the egg yolk needs to grow. So if you don't have the egg white parts, then the egg yolk itself, it's not gonna be alive, and it's not gonna grow into a chick. Does that analogy make sense?
Yes, it does. Thank you, Dr. Zheng.
Yeah. Why is the incoming hydrogen so hot? That's a great question. I was actually just asking myself that question early on. So the universe is very hot, basically everywhere. The question we should ask instead is actually why the temperature in the solar system and on the planet is so cold. How have we managed to cool everything down so that the human can exist? Because having a high temperature is common everywhere in the universe, but having the temperature so cold as cold as what's going on Earth is very rare. That's why we have been having difficulties to find human beings in other planets or in other solar system. So basically, the question is, the universe is hot everywhere, but we actually wanted to understand why the planet can be so cold, so that human beings can live here. Yeah.
Maybe I can ask a rather personal question.
Sure.
I'm going to call you Yong. How did you first get interested in astronomy? Where did that first drive come from?
So when I was in high school and college, I was always a student that wanted to understand physics, chemistry, biology, for example, but it did not occur to me astronomy was so interesting until I went to college and start my first research with a professor. And so my interest in astronomy might be very different from some of you who started with a little telescope in the backyard and looking at stars. I actually did not have that experience when I was a little child. So I started astronomy when I was in college and started doing research. And I realized actually dealing with data and dealing with telescopes is beautiful. If you ever have experience to visit an observatory, especially at night, and to have a tour around the observatory and look at the Milky Way, it's fascinating. So I definitely encourage you to do that. So that's one of the greatest inspiration, just by looking at the sky.
As much as we are loving this presentation, I know there's nobody more so than Tinka Ross who would like to second your thought about getting out and seeing the stars. She, like all of us, really wishes that we could be having this talk in the Mountain Theater and then leave the theater and go see the telescopes of the amateur astronomers. So you've helped to remind us of that important endeavor. Yeah. In fact, I've got to ask, in your what you've described as a village of Liaoyan, forgive my pronunciation, but do you recall being able to see the stars? Oh, really?
Absolutely.
It wasn't. Please.
Oh, it was. I remember when I was little, the sky was still very clear, but it's not like this anymore, actually. My most vivid memory was actually in college, my first year. I was in like Astronomy Introduction 101, and the teacher took us to an observatory. And it's a field trip for like 2 nights. And so we spent 2 nights in the observatory. It was really fun. You can see the Milky Way across the sky, very stunning. And we worked at night and then we slept during the day. So that's kind of have a completely reverse schedule. And it was super fun.
Excellent. Yes.
Yeah.
Do we have any more questions? All right, then I would like to thank both Tinka Ross here, the founder of the Mount Tam Astronomy Program, John Navas, the online engineer of the Mount Tam Astronomy Program, and of course, tonight's speaker, and I'll call you movie star for now at least, Dr. Yong Zheng of the University of California at Berkeley. By the way, Dr. Zheng, is it fair to call you an astrophysicist?
Yeah, sure. I actually would like to be called astronomer, but I think in my mind, they're interchangeable. So never mind. Yeah.
All right, good,
yeah.
Good. So as maybe with a joint unmuting of our microphones, we can all offer Dr. Zheng a heartfelt and audible round of applause.
Thank you.